Woohoo! Welcome back. Today we're going to be talking about trigonometric substitution. Say that 3 times fast. And this is going to be a subject that is probably going to be a little challenging. So I encourage you to pause the video, try things on your own, maybe even have a couple of practice problems in between so that you can reach out to tutors or to me, because this is a skill that is going to build over time. It's not necessarily going to be something that you understand right away. So be really patient with yourself. Hold yourself gently. Make sure you have your support carnivore. I have mine. Square Bear is back because we're going to be dealing with squares and square roots, and you know how he loves those. And I'm also going to make a note here that this subject has a lot to do with the Pythagorean theorem and with triangles and trigonometry. So again, make sure you have all of your trig rules handy. Have a sheet if you have trouble remembering all the different rules about what trig formulas there are and what the identities are and all that fun stuff. And then also, I am making this note that despite all of that, triangles are optional. So I'm going to show you a problem where I'll show you how to do it without triangles and then with triangles. And you can decide what you think is the best approach. Okay, so just to start off, I want to do a problem that has nothing to do with trigonometry for fun. So here's our funsies problem. Pardon me, Square Bear. And our funsies problem is this integral, radical 9 minus x squared. And the interesting thing to note is that there is an x here, and that is going to make all the difference in the world. Whenever I have an expression inside a square root or a radical, I think to myself, can I do a substitution? Because a u substitution is going to be way easier than a trig substitution. So let's see if it works. I'm going to go ahead and set u equal to 9 minus x squared. And then du is going to be 0 minus 2x dx, which is just the negative 2x dx. So far, so good. And then I realize that although I do have the 9 minus x squared right there, I do not have negative 2x dx. I only have x dx. Right, so I've got this x dx, so that's just that part. So just to make everything nice and easy, I'm going to go ahead and divide both sides by negative 2. So I get du over negative 2 equals x dx. What do you guys think? Kind of woohoo? So this is going to be our new x dx. And this u is going to be the thing that goes inside the radical, otherwise known as the radicand. I hate that word. And let's go ahead and substitute. So if I have the integral, and it's indefinite, so which is wonderful because I don't have to worry about the limits. I don't have to convert the limits into u world or convert back into x world. It's really lovely. So I'm going to rewrite this as the integral of radical, and 9 minus x squared is u, and then x dx is going to be du over negative 2. So if you guys can see this, here's my x dx, and here's my 9 minus x squared, which is u. Okay, so far so good. Pardon me. Okay, let's scooch this all up. Okay, I am going to go ahead and pull this negative 1/2 out in front, just so I don't have to deal with it inside the radical, or inside the integral. So I've got negative 1/2 times the integral of radical u du. Okay, all that matters, all that remains right now is for me to rewrite this as an exponent problem, so I can use the power rule. Woohoo! So this is going to be negative 1/2 times the integral of u to the 1/2 du. And then I can easily integrate that. It becomes u to the 1/2 plus 1 all over 1/2 plus 1 plus c. Now, if you really want to be pedantic about it, you could put the c in here and then multiply by -1/2 and get a new c. If you would like to do that. There is no reason to do that. When you integrate, you just end up with some constant, and so you really can just stick it on at the end like this, if you'd like. Okay, -1/2, and this is u to the 3/2 all over 3/2 plus c, and oops, there you go. And I've got a fraction where there's a fraction inside, and this is not good. So what we want to do is we want to rewrite this, and so I'm going to go up to the top, and I'm going to remind you, let me rewrite the whole thing so you can kind of see it all together. At u to the 3/2 all over 3/2 plus c. Okay, so if you have a fraction in the denominator, the way it resolves is it's actually equal to the reciprocal of that fraction. The fraction comes bopping up. Now, why does it flip upside down? Because fractions by their nature are division. So basically, this guy, u to the 3/2 over 3/2 is equal to u to the 3/2 divided by 3/2, which is u to the 3/2 times 2/3. So that's why it flips upside down like that. Okay, so it's basically a division problem. And we love this because now the 2's cancel. So it's going to make the whole expression a lot simpler. It's going to be -1/3 u to the 3/2 plus c. So far, so good? Woohoo. Getting a little hydration there. Now, I look back at the original of the problem and I realize the original problem is listed both with a radical and with x. So I got to translate this answer. First off, this exponent is lovely. It helped us do the work, but we got to translate it back into radical land. And also, the problem was in x, so I need to resubstitute back into x. Okay, so at this point, what I'm going to do is I'm going to go ahead. I'll do the substitution first. U is 9 minus x squared. I don't know if you can see right there. Oh, that 3 turned into a little blob, didn't it? Okay. Now, it's very tempting at this point to think distributive property. Distributive property does not work with exponents. Exponents and pluses or minuses, they don't work well. They just hate you, and they hate everything you stand for. So what you got to do is just say, okay, I cannot fix this, but I can translate it. Basically, this means power 3, so we're going to cube something and take the square root. It turns out, as long as your expression is defined, which we're going to assume that we're not using imaginary numbers, you can do this in either order. So what does that mean? This could either be 1/3 times radical 9 minus x squared, the whole thing cubed, or it could be -1/3 times radical 9 minus x squared cubed. So the square root and the cube can go in either order. It's up to you which one you want to do first. And we're done. Woohoo! Yay! So that was just a little review. When you get a problem with square roots and nasty stuff running around, I would recommend that you always look to a U substitution first, because they're much, much easier than trig substitutions. So that's what I recommend. If you can do a U substitution, do a U substitution. Now, given that I know how complicated the next problem is, I'm actually going to end the video here. I know it's a real short and sweet one. So we're going to do a little break, and then we will get on to the meat of this section, the trigonometric substitution. So go take a little break. It's never too soon to hydrate. Get yourself a little protein, something to eat, maybe something to drink, and go look at something green, touch grass, and I will see you in the next video. Woohoo! Math on.